Hi, I am Ma'am Jovelyn, a pre-service teacher from Aklan State University main campus, taking a Bachelor of Secondary Education major in Science. Today, we will learn about the two main forms of energy, which are the kinetic energy and the potential energy. Upon having our discussion, we aim to achieve these following goals. First, define what is kinetic and potential energy. Second, solve kinetic and potential energy related problems using its formulas. And third, relate kinetic and potential energy to real-life situations. Let's begin with a question. What is energy? Energy is defined as the ability to do work. Without energy, we aren't able to do any work, and work is a method of transferring energy. You can ride a bicycle and play volleyball because of energy. So what are the two main forms of energy? Its two main forms are kinetic energy and potential energy. What is kinetic energy? Kinetic energy, or capital letter K and capital letter E, is defined as the energy of a moving object and often called the energy in motion. The word kinetic comes from the Greek word kinetikos, which means moving. Examples of real-life activities that illustrates kinetic energy: a basketball player dribbling. It is an example of kinetic energy because the ball is in motion, possessing energy of movement as the player's hands propel the ball upward and downward. A bicycle in motion. It demonstrates kinetic energy fueled by the energy in motion. It stems from three key factors: the bicycle's movement, the combined mass of the bike rider and accessories, and its velocity. A moving volleyball during a game. This example shows kinetic energy because it possesses energy in motion generated by the player's action by hitting. We may also infer to this that the faster an object moves, or the more massive it is, the greater its kinetic energy. These are just some examples of kinetic energy that we observe in our day-to-day living. There are many more that we cannot totally mention one by one. What is the potential energy? Contrary to kinetic energy, potential energy, or capital letter P and capital letter E, is defined as the stored energy due to the position of the object. We call it potential energy because it has the energy that is ready to be released. The word potential comes from the Greek word kinetikos, which means power. There's something inside, but it's not moving or not yet moving. Examples of real-life activities or situations that represents potential energy. A stretched bow. This embodies potential energy due to its stored tension. As the bowstring is drawn back, energy accumulates in the elastic material, awaiting release. This poised state, with the arrow ready to launch, exemplifies potential energy. Unreleased water from the Angat Dam. Water stored possesses potential energy due to its elevated position, massive volume, and confinement. As the water remains unreleased, its potential energy builds up. A yo-yo in someone's hand. This example portrays potential energy because of its elevated position above ground level. The tension in the coil string and the yo-yo's mass all contribute to stored energy. So we may conclude here that the potential or stored energy of an object depends on its position or condition, such as an object held above the ground or a compressed spring. These illustrations represent a few of the numerous examples of potential energy encountered in daily life. Having explored the concepts of kinetic and potential energy, you may now wonder or ask the question, how are they calculated? Don't worry, I got you. So how do we calculate kinetic energy? To calculate kinetic energy, we need two primary units. First, the unit of mass, which is the kilogram, where it measures the object's mass. And the second, the unit of velocity, which is the meter per second, where it measures the object's speed. And the derived unit of energy, named after James Joule, is Joule, or capital letter J. It represents the energy expended when a force of 1 Newton acts over a distance of 1 meter. So 1 kilogram meter square per second square is to 1 joule. Kinetic energy is presented with this formula, where Ke stands for kinetic energy, m for mass, and v for velocity. We read this as kinetic energy equals 1/2 or 0.5 times mass times velocity squared. This energy depends on the mass and the speed of the body or an object. This equation also reveals that the kinetic energy of an object is directly proportional or equal to the square of its speed. This means that if the speed of an object is doubled, its kinetic energy is increased as well. With that, let's have a sample problem. Let's try to solve it. If a 0.2 kilogram ball is thrown with a velocity of 6 meters per second, what is its kinetic energy? First, let's identify what are the given values. We have the mass, which is 0.2 kilograms, and the velocity, which is 6 meters per second. Second, what is the required on our problem? We have to find the kinetic energy. Third is our formula. And fourth, the solution. We will just substitute the given values from our formula and simplify. After completing the solution, we will come up to the answer, which is 3.6 joules. Let's now move on how to calculate potential energy. To calculate potential energy, we need 3 primary units. First, the unit of mass, which is the kilogram, where it measures the object's mass. Second, the unit of gravity, which is the meter per second squared, the acceleration due to gravity, 9.8 meter per second squared. And third, the unit of height, which is the meter, where it measures the object's height. And the derived unit of energy representing energy expended or stored is the joule. The formula for potential energy is PE is equal to mgh, where PE stands for potential energy, m for mass, g for gravity, and h for height. This is expressed as potential energy times gravity times height. Potential energy depends on these 3: mass, gravity, and height. Let's try to solve this sample problem. What is the potential energy of a 1 kilogram book when lifted to a height of 0.5 meters above the table? First, let's identify what are the given values. We have the mass, which is 1 kilogram, the acceleration due to gravity, which is 9.8 meters per second square, and the height, which is 0.5 meters. Second, what is the required on our problem? We have to find the potential energy. Third is our formula. Fourth, the solution. We will just substitute the given values from our formula and simplify. Upon completing the calculation, we arrive at 4.9 joules. That's it! A stationary bike on top of the hill has stored energy called potential energy due to its elevated position. But when the bike starts moving downhill, gravity converts the stored potential energy into kinetic energy, the energy in motion. This transformation illustrates the principle of conservation of energy, where energy changes forms but remains constant. The potential energy is not lost. It is transformed into kinetic energy. demonstrating the dynamic interplay between these two energy types. This concludes our exploration of kinetic and potential energy. I hope today's discussion sparked curiosity and inspired further learning for you. Thank you for listening and for watching this video.